guys, welcome back to our channel. This is Remy from Do and Learn. So today we are here to learn Quine McCluskey's method to solve Boolean expression, or the idea here is to simplify the Boolean expression. So this QM method is also called as tabulation method. So the main reason behind using this method is that using your K-maps, we can solve 4-variable Boolean equations, or we can simplify 4-variable Boolean equation, or even we can go to 5 variables. But if your Boolean equation or Boolean function consists of more than 5 variables, then it is not possible to solve using K-map. So in that situation, we will be using QM method or tabulation method to solve it. So let's get started. So let's say we have a Boolean function f of w, x, y, z is given by the sum of minterms 0, 2, 4, 5, 6, 7, 8, 10, 13, and 15. The first step here is to arrange these minterms in ascending order. So let me take each minterm. So the first minterm is 0. I'll write the binary equivalent of this, that is 4 zeros. Because I have 4 variables here, I limit my binary equivalent to 4 bits. Then I have the minterm 2, which is nothing else but 0, 0, 1, 0. Then I have the minterm 4, which is 0, 1, 0, 0. Then I have the minterm 5, which is 0, 1, 0, 1. Then minterm 6, which is 0, 1, 1, 0. Minterm 7, which is 0, 1, 1. Then we have minterm 8, which is 1, 0, 0. Followed by minterm 10, which is 1, 0, 1, 0. Then we have minterm 13, which is 1, 1, 1, 0, 1. Then we have minterm 15, which is 1, 1, 1, 1. So we will rearrange this minterms or these minterms in the order of number of ones present inside them. So if you take the first minterm, I don't have any number of ones. So the number of ones present here is 0. If I take the second one, the number of ones present here is just 1. If I take the third one, it is again 1. But if you take the fourth one, I have 2 ones present here. So the number of ones is 2. Here also the number of ones is 2. I'm checking the number of ones present inside each and every bit location. So here it is 3. Here it is 1. Here I have 2 ones present inside them. So here I have 3 ones. So here I have 4 ones. So I will arrange them in the ascending order now. So let me take the first one, 0 number of ones. So there are 4 zeros. So this is one set for me. The second set will be having 1 number of ones. So the second set starts with 2. So it is 0, 0, 1, 0. Then I will take 4, which is 0, 1, 0, 0. Then I will take 8. 8 also has only 1 1 inside them. So 8, which is 1, 0, 0. So that's it. This set is over. Now I will consider taking the set which has got 2 number of ones inside them. So I start with number 5. So 5 has 0, 1, 0, 1, which is 2 ones. Then I take number 6, which is again 0, 1, 1, 0. Then I take number 10, which gives me 1, 0, 1, 0. Then that's it. I think, we'll close this set. Then we will move to the next number of ones, that is 3. So I will take number 7, which is 0, 1, 1, 1. Then you take number 13, which is 1, 1, 0, 1. I think that set is also over. Now we will consider the element which is having 4 ones, which is nothing else but 15. 1, 1, 1, 1. So we will just roll back and check whether we have taken all the terms here. So we have 1 plus 3 plus 3, that is 6 plus 1, 7, 7 plus 3, 10. So totally 10 elements are over. So moving to the next step, we are going to group these elements from every set. So the grouping has to be made in such a way that you have to take every element of every set and compare with all the elements of the other set. And after comparison, we will group any 2 elements only if there is 1 bit change between those 2 numbers. For example, if I take 0 and 2, I will consider them as a proper group if only 1 bit changes between both the numbers. So if you consider 0, which is nothing else but 0, 0, 0, 0, I'll consider 2, which is nothing else but 0, 0, 1, 0. If you take the first MSB, both the numbers are same, both the bits are same. The second bit also same. But you take the third bit, it is changed, but the fourth bit is same. So in this comparison, I have only one bit that is changed. So I can accept this as a proper group. I will put it like this. Suppose if I consider 8 and 5, let's take 8 and 5 for example. Okay, so if I take 8, that is 1,000,000. If I take 5, that is 0,101. So if you compare these two, the first bit is changed, second bit is also changed, third bit is same, and fourth bit is changed. So in this comparison, I have more than one bit that is changed. So actually we have three bits that are changing here. So we cannot consider this as a proper group. So that's how we are going to group it. So let's start the grouping process. So first I will consider 0 and 2. So 0 and 2 can be a proper group. So I will write it in such a form that wherever I find a change of bit, that will be notified as dash. So 0, 0, dash 0. So when I compare 0 and 2, 0, the first MSB is same, so that is 0. The second value is also same. The third bit is changed, that is represented as a dash, and the fourth bit is same. Now after grouping them, we can just put a tick mark just to highlight them that they are grouped. Now I'm going to consider 0 and 4. So 0 and 4. So 0 and 4 can be grouped in such a way that 0, dash, 0, 0. Now 0 and 8, that is also possible. So 0 and 8 is a good group where I have dash, 0, 0, 0. So the first set and the second set comparison is over. Now I'm going to do the comparison between the second set and the third set. So I have to compare 2 and 5. If I compare 2 and 5, I have 2-bit change. The second bit is changing and the third bit is changing. So 2, 5 cannot be a proper group. So I will go for 2 and 6. So if I compare 2 and 6, that can be a proper group, because if you take 2, that is 0, 0, 1, 0. If you take 6, that is 0, 1, 1, 0. So in this, the first bit is same, second bit is changed, third and fourth bit are same. So this can form a proper group. But the final outcome is 0, dash, 1, 0. I will just mark 6. Now 2, 10 can also be a proper group, because 2, 10 will give me dash 0, 1, 0. I will mark 10 also. Now comparing 4 and 5. So the first element in the second group is over, and I'm going to take the second element in the second set and compare it with the third set fully. So comparing 4 and 5, 4 and 5 can form a proper group. So 4 and 5 gives me 0 is same, 1 is same, 0 is same, and last bit is changed. So it is 0, 1, 0, dash. I will just mark 4 and 5. Since 4 is already marked, I am not marking it again. Now take 4 and 6, which gives you 0, 1, dash 0. So 4 and 6 is also a proper group. 0, 1, dash 0. Now comparing 4 and 10, I have 2-bit change because the first bit is changed and the second bit is also changed. So I am not going to group them. Now 4 is over. Going for 8. 8 and 5, it's not a proper group because the first 2 bits are changed. 8 and 6 is also not a proper group. The first 2 bits are changed. 8 and 10 would be a proper group because if I compare 8 and 10, that gives me 1, 0, dash 0. 1, 0, dash 0. So that's it. The second and the third set are over. I'm closing this group. Now I'm going to compare the third set with the fourth set. So if you compare the third set with the fourth set, I'll just move my page a little bit. So you can compare 5 and 7. So if you compare 5 and 7, that forms a proper group. So that is 0, 1, dash 1. 0, 1, dash 1. So I can just mark 7 here. Now comparing 5 and 13, that also is a proper group. So 5 and 13, so that gives me dash 101. That's it with 5. We move to 6, 7. 6, 7 is also a proper group. So that gives us 0, 1, 1, dash. So comparing 6 and 13. So 6 and 13, The first bit is changed, second bit is same, third bit is changed. So I cannot come and take 6 and 13 as a group. So moving further, take 10 and 7. The first two bits are changed, so it's not a proper group. 10 and 13. Again, the second and the third bit are changed, so 10 and 13 cannot form a proper group. So we are done with the next set also. We will close this. Now comparing the third set with the last set. So 7 and 13 has to compare with 15. So moving further, so 7 and 15 would form a proper group. So that will give us dash 1 1 1. So 15 is marked. Now 13 and 15, 13 and 15 again will form a proper group. That gives me 1 1 dash 1. So that's it with the next step. So totally we have 1 2 3 4 5 5 plus here I have a 5, so 10. So 10 plus at the top I have 3, so totally I have 13 groups formed. So the next step is to repeat the same process between these set of elements. So we have to compare the first step here, first set with the second set, and then the second set with the third set, and progressing further the third set with the fourth set until we end up. So let's start comparing the first set and the second set. So I will compare 0, 2 and 2, 6. So if you compare 0, 2 and 2, 6, that cannot form a proper group because the first bit is same, but the second and third bit are changed. So comparing 0, 2 and 2, 10 is also not possible. Comparing 0, 2 and 4, 5, the first bit is same, second bit is changed, the third bit is also changed, so we cannot take that as a proper group. Comparing 0, 2 with 4, 6, I think 0, 2 and 4, 6 can form a proper group because the outcome of this 0, 2 and 4, 6 will be the first bit is same, second bit is changed, third and fourth bit are same. So it is 0 dash dash 0. So I have marked 0, 2 and 4, 6. Comparing 0, 2 with 8, 10, that also forms a proper group. So 0, 2, 8, 10. So that gives me the first bit alone is changed, other three bits are same. So that is dash 0 dash 0. So moving further, we have to compare 0, 4 with the rest of the elements. So if you compare 0, 4 and 2, 6, that forms a proper group. So 0, 4, 2, 6, which gives me the first bit is same, second bit is same, third bit alone is changed, and the fourth bit is same. So that gives us 0 dash dash 0. So likewise, 0, 4, when we compare with all the other terms, we don't find a proper group here because all the other terms will give us more than one bit change. So moving to 0, 8. So if you take 0, 8, then you compare with 2, 6, that cannot be grouped because 2 bit changes there. 0, 8 with 2, 10. Let's try that out. So the first bit is same, second bit is also same, third bit is changed, and the fourth bit is same. So we can take 0, 8 and 2, 10 as a group. So 0, 8 and 2, 10. So when you take this as a group, so the final outcome of the group is dash 0 dash 0. That's all written. So comparing 0, 8 with the other terms, we don't find a proper group because there will be more than one bit change. So we'll close the set. Now we have to compare the second set with the third set. While doing so 2, 6 is compared with 5, 7. That cannot be grouped. 2, 6 with 5, 13 is also not a proper group. 2, 6 with 6, 7 is also not a proper group. So then we take 2, 10 with the other three elements. I don't think so. 2, 10 can be compared with the other three elements because they don't form a proper group. Let's check 4, 5 and other three elements. So if you go for 4, 5 and 5, 7, no, it cannot be grouped because the third element and fourth element are changing. 4, 5 and 5, 13 is also not a proper group. But what about 4, 5 and 6, 7? I think that could be a proper group because when you take 4, 5 and 6, 7, so it is 0, 1, dash, dash. So we can take 4, 5, 6, 7. So that gives us 0, 1, dash, dash. Now moving further, 4, 6 compared with 5, 7, that is also a proper group. So 4, 6, 5, 7, that also gives us 0, 1, dash, dash. So when you compare 4, 6 and 5, 7, the first two bits are same, third bit is also same, but the fourth bit is changing. So that is a proper group. Now further, if you compare 4, 6 with 6, 7, it doesn't form a proper group, and I don't think so 8, 10 will form a proper group with the rest of elements. So we can close this. Now moving further, we have to compare the third set with the fourth set. So if we compare the third set with the fourth set, so we have to compare 5, 7 with the rest of the elements here. So if I take 5, 7 and 7, 15, that's not a proper group because we have more than 2-bit change. So if you take 5, 7 and 13, 15, I think that's a proper group. So 5, 7, 13, 15. So this will give us dash 1, dash 1. So I will tick 13, 15. So comparing 5, 13 with 7, 15, that forms a proper group. So that's actually a proper group. So 5, 13, 7, 15. So that gives us again dash 1, dash 1. So taking further, we cannot find any other proper group. 6, 7 doesn't match with any other elements. So we will close this. So if you find in this step, we cannot group these further with any of the elements, so we cannot proceed further. So we have to stop here. So in this, we have certain repeated elements. So this one is repeated here. I'm just comparing the pattern that is formed, and this one is repeated here. Then we have a repetition here. Again, there is another repetition here. So when you have repeated elements, you can just consider one and discard the other. So let me discard this one. I'm going to take this into consideration. So let me discard this one. I'm going to take this one into consideration. So out of these two, I will discard the second one. I'll take the first one. And out of these two, I'll discard the second one. I'll take the first one. So as of now, the selected elements or the selected groups are, so let me put it into marking. So this is the first group. So this will be the second group. These two are discarded. So this will be the third group. This is fourth group. After this, you have to just roll back and check whether we have any unmarked elements here. So if we have any unmarked elements, those elements will also be considered as the next group. So let's say, suppose we have an unmarked element here. Suppose if we have 6, 7 as unmarked, then we will consider that as the fifth group after the fourth one. And we have to roll back to the previous stage, and we have to check throughout the whole problem whether there is any element that is left unmarked. So as of now, in this problem, we don't have any element that is left unmarked. So the elements or the groups what we have considered are our implicants. So the implicants what we have obtained here can be written as, the first implicant what we have here is 0, 2, 4, 6, that is 0, double dash 0. The second implicant is, so let me write it here. So 0, 2, 4, 6, 0, double dash 0. So 0, double dash 0. And the second implicant what I have here is 0 dash 0 dash. The third implicant is 0, 1, double dash. And the fourth implicant is dash 1, dash 1. So we have totally 4 implicants here. So the next step is to form the prime implicant table. So let's form the prime implicant table. So the prime implicant table is formed in such a way that the column headers are filled up with the minterms that are given in the question, and the row headers are filled up with the groups that we have formed. So as we know that we have 4 implicant groups. The first implicant is 0, 2, 4, 6. So I will write it down here, 0, 2, 4, 6. The second implicant is 0, 2, 8, 10. So let me write it as 0, 2, 8, 10. The third implicant is 4, 5, 6, 7. So 4, 5, 6, 7. And the final implicant is 5, 7, 13, 15. So 5, 7, 13, 15. So let's mark this. So I have 0, 2, 4, 6. So 0 is marked, 2 is marked, 4 is marked, and 6 is marked. Then I have 0 to 8, 10 in my second row. So 0, 2, 8 and 10. Then I have 4, 5, 6 and 7, the third row. So 4, 5, 6 and 7. And finally in my fourth row, 5, 7, 13 and 15. So 5, 7, 13 and 15. So my next step is to identify any column that has got only one tick mark. So those columns will give me the essential prime implicants. If I take the first column, I have more than one tick mark, I leave it. The second one I leave it, the third one I leave it, fourth I leave it, 6, 7. But if you take the column with the header 8, I have only one tick mark, so I will select this one. Even the column 10, I'll select this one. Even 13 and 15, I'll select this one. So I will identify the row header of the columns which has got only one tick mark. So I will select them. So those row headers will serve as the essential prime implicants. So my essential prime implicants are nothing else but 0, 2, 8, 10 and 5, 7, 13, 15. So these two implicants are mandatory to be in my solution. Now my job is to find out the left out prime implicants. So I have two more rows that are left out. So let me start identifying which are the prime implicants that will fit into my solution. So let's start analyzing the first row, which is 0, 2, 4, 6. I have to take this implicant if the value present inside this implicant is not present inside my already taken EPI or already taken essential prime implicants. What I mean is, so I have 0, 2, 4 and 6. 0 is already taken here. 2 is also already taken here. 4 is not at all taken anywhere. 6 is also not at all taken anywhere. So I can consider this as one of my other solution. Now going to the next left out part, 4, 5, 6 and 7. 4 is already taken in the recently taken PI. 5 is already taken in the EPI. 6 is already taken in the recently taken PI. 7 is already taken in the EPI. So if I take 4, 5 and 6, 7 again, that will be a repetition. So there is no need for me to take this PI. So the final solution for PI is just 0, 2, 4 and 6. So you have to repeat this process if you have any other PIs left out and check them with the already existing element to form the final solution. So in order to form the final solution, the function is given as sum of the essential prime implicants and the prime implicants. So this is equal to 0, 2, 8, 10. This is my first essential prime implicant plus 5, 7, 13 and 15. This is my second essential prime implicant. And the third one, which is my prime implicant that is selected, which is 0, 2, 4 and 6. So the final function can be formed with f is equal to 0, 2, 8, 10 can be replaced by the group version of it, which is dash 0 dash 0 plus 5, 7, 13, 15 is replaced by dash 1 dash 1 plus 0, 2, 4, 6 is replaced by 0 dash dash 0. This can be further replaced by the input variables. So every element here corresponds to the input variable w, x, y, z. So if we have a dash, that element is discarded. If I have a 0, that element is complemented. But if I have a 1, that element is taken in the normal form. So the first element is dash 0 dash 0. So w is discarded, x is complemented, so x dash, y is discarded, z is complemented, so z dash, plus the second element, w is discarded, x is in normal form, y is discarded, z is in normal form, plus the last element, w is in complemented form, x and y are discarded, so then I have z which is in complemented form. So my final solution for this problem is given by f equal to x dash z dash plus xz plus w dash z dash. So your answers might vary. If suppose instead of selecting 0, 2, 8 and instead of selecting 0, 2, 4 and 6 as the prime implicant, you can prefer 4, 5, 6, 7 if it satisfies your answer. In a similar fashion, we could have taken these groups 5, 13, 7 and 15 instead of 5, 7, 13 and 15. But since they produce the same results, we have just discarded one and taken again. So hope you can understand this video. If you have any queries, please put it inside the comment box. I would be happy to answer that. Please like and share and subscribe to our channel. I'll see you in the next video. Thank you.